Okay, solving systems of elimination or systems of equations using elimination is my personal favorite. I think it's the easiest. Long story short, you always have to have both equations in standard form. And remember, that is ax plus by equals c. The only thing that you necessarily don't have to have is you don't have to have that a be positive. You'll see negative a's, but that's okay. But in general, ax plus by equals c. This is what you do. So you have them lined up. You want to cancel out either your x's or your y's. Sometimes you get lucky and they're already kind of set up for you. What you need to do is you need to go ahead and look at your coefficients. Okay, so all these are 1. I want them to cancel. So 4 minus 4 is 0. And negative 3 plus 3 is 0. So I want them to cancel out. So if I look at my x's, 1 plus 1 is 2. However, if I look at the y's, negative 1 plus 1 is 0. So I'm going to go ahead and add these up. And I'm going to add and subtract, or add vertically. So 1 plus 1 gives me 2x. I'm just like combining like terms. Negative 1 plus 1 is 0, so those are going to cancel. 1 plus 3 is 4. Now I divide both sides by 2. X equals 2. Now it's up to you. Y'all know how I am. I always like to just go ahead and go back to the first equation. So I'm going to go to the side. I'm going to rewrite it. X minus y equals 1. Supposedly my x is 2. So I subtract 2 on both sides. Negative y equals 1 minus 2 is negative 1. And I divide both sides by negative 1, giving me y equals a positive 1. Remember, the solution is that ordered pair. So those ordered pair x, y. So 2, 1. Next one. So once again, I'm looking at the coefficients. If I look at the coefficients of x, 3 and 2 are completely opposite. So I'm just going to hold up on there for a second. If I look at the y's, I have the same coefficient, which is negative 1. But remember, I want them to be opposites. So it's up to you which one you change. I'm just going to go ahead and change the bottom one by multiplying everything by negative 1. Okay? When I do this, this is where people get all weird and confused. I'm just going to go to the right. I'm going to rewrite the top one that I've not changed at all. This bottom, multiplying everything by negative 1, is the same thing as just changing it to the opposite sign. So this is now 2x plus y equals a positive 24. Now I add my systems together. 3 plus 2 is 5x. Negative y plus y, those cancel. And then 26 plus 24 is 50. Divide both sides by 5. X equals 10. I take my top equation, which is 3x minus y equals 26, and I plug in that x is equal to 10. So x is equal to 10, and now I solve that equation. So 3 times 10 is 30. Subtract 30. 26 minus 30 is negative 4, and divide both sides by negative 1. So y is equal to 4. So my solution is the point xy. So my x value is 10, my y value is 4. Next one. All right, I look at my x coefficients, 1 and 5 are not the same. I look at my y coefficients, 1 and negative 2 are not the same. So now I'm going to have to play around a little bit. Personally, I just like to get rid of, if the x's don't go together and the y's don't go together, then I just like to get rid of my x. So I have to ask myself, what can I multiply? And remember, I want negative, or I want opposite, but the same coefficient. So if my coefficient of x is 5, I want to multiply this top one by negative 5. That way they're opposites, but they have the same coefficient. So now I multiply. Negative 5 times 1x is negative 5x. Negative 5 times y is negative 5y. and negative 5 times negative 9 is a positive 45. I rewrite the bottom one that I have not messed with at all exactly as I see it. Now, I look at my x's, same coefficient, they're opposites, so I add. Negative 5 plus 5 cancels. Negative 5 minus 2 is negative 7y. And then 45 plus 32 is 77. Now I divide both sides by negative 7. My y is equal to negative, sloppy looking. Y is equal to negative 11. I take my top equation, which is x plus y equals negative 9. And notice how I'm taking the equation before I transformed it. I'm just taking the original equation. And I plug in y is equal to negative 11. So x plus negative 11 equals negative 9. So that just becomes x minus 11 equals negative 9. And add 11. So x equals a positive 2. Therefore, my solution is the point xy, which is 2, negative 11. All right, my x's, the coefficients are not the same. My y's, my coefficients are not the same. So remember, you could change the y and multiply everything by 4 on the top, but I just like to get rid of my x's if I can. So I need to decide, my bottom one's already negative 4, my x coefficient. So I need to determine what I need to multiply the top one by to get the opposite of negative 4. The opposite of negative 4 is a positive 4. So I'm going to multiply everything by 2. Because 2 times 2x is 4x. 2 times y is a positive 2y. And then 2 times 3 is 6. Now I rewrite the bottom equation exactly as I see it. So now I look at my x's. They are opposites, but they have the same coefficient number. So I can add them. 4 minus 4 cancels. 2 minus 4 is negative 2y. And 6 minus 8 is negative 2. Divide both sides by negative 2. Y equals a positive 1. I take my original equation, the top one, which is 2x plus y equals 3. That one. And then I plug in y equals 1. So 2x plus 1 equals 3. Subtract 1. Divide by 2. X equals 1. So my solution is the point xy, which is 1, 1. All right, my x's do not have the same coefficient. My y's do not have the same coefficient. So this one's a little sneaky because I can't multiply 2 by any number to just get 5. I can if I'm looking at my x coefficients. If I'm looking at my y coefficients, there's nothing I can multiply 3 by to get 2 or vice versa. So when you have numbers that do not evenly go into each other like these do, we actually are going to have to manipulate both equations. Now once again, I always like to try to get rid of the x if I can. So I'm going to multiply the top one by whatever that bottom coefficient is, which is 5. So 5 times 2x is 10x. 5 times negative 3y is negative 15y. 5 times 21, I think, is 105. I hope so, at least. Now this bottom one, I do 2 because that's what that one was, or the other coefficient. But once again, I would need them to be opposite. So I'm going to do it by negative 2. Negative 2 times 5x is negative 10x. Negative 2 times negative 2 is a positive 4y. And then negative 2 times 25 is negative 50. All right, so now my x's are the same coefficient, but they're opposite, so I can add them up. Those are going to cancel. Negative 15 plus 4 is a negative 11y. 105 minus 50 is a positive 55. And I divide both sides by negative 11, giving me y equals negative 5. I take my top equation that I have not messed with, 2x minus 3y equals 21, and I plug in y is equal to negative 5. So 2x minus 3y is -5. -3 times -5 is a positive 15. So now I subtract 15 and I divide by 2. X equals 3. So my solution is the point xy, which is 3, -5. And last one. All right, I look at my x's. They are not the same. The y's are not the same. So I've got to mess with one of them. I'm going to go ahead and manipulate this bottom one. And I'm going to make it -2 so that my x's cancel. So this time the top one did not change. So I just rewrite 2x plus 4y equals 0. And then I'm going to distribute the bottom. -2 times x is -2x. -2 times 2y is -4y. And -2 times 3 is -6. All right, my x's are the same coefficient, but they're opposites. 2 minus 2 cancels. 4 minus 4 cancels. So over here, I don't have anything. I have 0. Over here, 0 minus 6 is -6. 0 never equals -6. So this is no solution. Now, if I would have had the same scenario, but it came down to 0 equals 0, that one would be an infinitely many. Right? So if the x and y is canceled on one side and then over on the other side I also had 0, that one would be an infinitely many. Okay? All right, here are your practice problems. Make sure you use the elimination method. You have to use the elimination method.